We are significantly behind Miss Martin's class and getting, seems like further and further behind. While I was out, we got further behind, and we have got to keep moving on. So we're going to have a quiz on this exponential growth stuff tomorrow. So if you're having trouble with it, today needs to be the day you're really paying attention so that you can figure out whatever is giving you trouble. All right, so our first question is a how much question. Lakin invests $8,000 in an account that gets 7% APR compounded annually. That APR is annual percentage rate. If she does not make any deposits or withdrawals, how much money will be in the account after 8 years? Okay, Jada, what do you think? Oh, let me fix that. There we go. All right, do you guys agree? Starting value is 8,000. Does that sound good? Okay. 7%, if we change it to a decimal, is 0.07, and we put the 1 in front of it. So that looks great. 8 is our time, so it goes there as our exponent. And as long as she typed it in right, that seems correct. I didn't type it in. Somebody check her, make sure she didn't hit a button incorrectly, but I think it looks good. In my opinion, I think these are the easiest ones because you've got your start value, you've got your percentage growth, and you've got your time. You just have to plug it all in. Okay, good. All right, so I think these are the easiest. You're going to see several of these, but you're also going to see some like number 2 and number 3. Not as many of number 2 and number 3, but you are going to see some. Number 2 is a how long question. Which one of our variables, A, B, X, or Y, stands for the time? The X, right? So if you see that the question is saying how long, you're going to be solving for the X in the problem. Okay? So for this particular question, Peyton, how much do we begin with? Is that at the beginning? 15. No. I need something like that 7%, right? That I had on the last problem, but I don't have it. And 1,000,000 is not the percent. Like it would have a percent with it. So it looks like that information's missing. But there's a word here that we're going to use that's going to replace that percentage, right? So that word tells us the sample triples. So it means it's multiplied by 3. So when you see that triples, doubles, quadruples, I'm probably not going to go past that because I don't know what it means to, I don't know the word for multiplies by 5. I'm not sure. We would multiply by 3 right there. That we don't change anything for it. You don't add 1 or do anything like that. Just use a 3 if it says triples. And then I don't know what X is because that's my time. That's what I've got to solve for. So this is my equation, right? Y equals 15 times 3 to the X power. But I can't solve that. I can't type it in because there's an X, right? So what I'm going to have to do, these are the ones that we're going to use Desmos for. You have to use Desmos. On number 1, you could use Desmos to do it if you want, but the calculator, just the regular calculator, will do number 1. The regular calculator technically will do number 2 also, but it's just so much easier to use Desmos. I'm going to use it. It won't just, you can't just type it in. So we'll pull up Desmos here, and type in my equation. Y equals 15 times 3 to the x power. All right? I want to know when this equals what? 1 million. So in the second line, I'm going to type in y equals 1 million. But I don't see anything. Why do I not see anything? I'm zoomed way in, right? I could try to zoom out, and it will eventually work. You really got to zoom out a really long ways. You can see, like, I still don't see anything. I've still not got to 1 million. There it finally is. It will technically work if you do it that way. But it is better to go here and hit the wrench. Yes, Jada. The quickest way to do it is just hit Shift 6, and it'll go up to the exponent. Yeah, that's the quickest way. You can also do it down here from the from this menu. That right there will get you up to the exponent as well if you like that better than the keyboard. So if you hit the wrench over here, I want everybody to type this into their Desmos right now. Okay? So Julian, go Desmos, type it in. Because sometimes it looks really, really easy, but then it's very difficult whenever you actually try it on your own. Miss White, the calculus teacher that had calculus before I did, that retired several years ago, she would say that she would tell her students that using the calculator looks really easy, but it's not. It's similar to whenever she wanted to, she saw her daughter jumping on the trampoline, and she thought that it looked really easy and that she could do a split jump, so she got up there and tried, and then she peed in her pants. So sometimes it looks way easier than it really is. So please follow along. All right, so if you hit the wrench up here in the corner, what do we need to change? We need to change the y-axis because we need this y equals 1 million right here, right? So I'm going to just go over here and change that last number to 1 million. And then it may still not show up good, but usually if you just zoom out just a little bit after that, you'll get the right graph. Okay, so I want to see everybody having this graph on their screen. Julian, you got it? You got to sleep 2 extra hours this morning, Julian.
I won't be sleeping.
So it'll work if you do it like that, but if you hit the house button, and then you change the wrench, and you'll change that number right there to 1 million, it'll be a little bit better as far as like being able to see it. Okay. Go hit your wrench for me. This bottom number right here, change it back to 0. That one's fine, visual. Change it back to 0. Don't. Hit the wrench and change just that top number right there. And I'll have the one where you're at. See if you can get it better. Make sure. Pretty good. You just zoomed out, so it makes it where you really can't see it very well. Hit the house button, wrench, and then change that to 1 million. And if you zoom out just a little bit more, it should show up there. Good. Good. All right, yours, Cameron, is also like, it'll work, but it's a little hard to see. Hit the house button first, and then hit the wrench and type in 1 million in that, right here, you want to put the line there. So type in 1 million there. All right, yeah. Go do the second number, not the first. Yeah. Change it to 1 million. and now just zoom out just a little bit more. That's good. Okay. Right here. Yeah. Yeah. Now type in 1,000,000. 6 zeros. Don't do the comma. Okay. And then go back to the screen and just zoom out just a little bit more. It'll probably show up. Let's see. I think you have too many zeros over here. Oh, don't put the commas. It doesn't know what to do with the commas. Yeah.
Okay.
Whenever you get that like exclamation point there, it means that it's not graphing that because it's got some issue. Okay. All right. So I think everybody's got the graph here. So once you get it graphed and once you can see it, all you have to do is click on one of the lines. A point's going to pop up right here, and you're going to see I've got 10.11, 1,000,000. Now the question is saying how long, not how much. We knew it was going to be 1,000,000, right? So that 10.11 is what we want. So 10.11 is going to be our answer. It's tripling every hour, so it's going to be 10.11 hours.
How do you do that, Rich?
How do you do what? Yeah, when you hit the wrench, this, for y-axis, that second one, that second number right there, you want to change it to 1,000,000. Okay. All right, so questions on number 2. Yes. I just clicked on the graph right here, and then I've got that gray dot that shows up where they intersect. And if you'll just hover over that, it should show up. And you'll get 10.11, 1,000,000. 1,000,000 is the number of bacteria. We want the X value as our time. Okay, other questions on that? So if you have to solve for the X, we can't solve for the X. There is a way. You have to know how to do logarithms. You won't do that until at least Math 3. So we can't solve for X, so we have to just graph it and figure out when that happens. Okay. All right. So the last type of problem that you're going to get is one like we see here on number 3, and these are the ones that ask you for your growth rate. And so if they ask you for your growth rate, it's going to be the B that is missing. Okay? So, in this case, population of Algebreville was 4,293 in the year 2000. By the year 2018, the population of Algebreville had increased to 5,621. Assuming that the population grew exponentially at a consistent rate, what growth rate did the population increase by each year? Round your answer to the nearest thousandth of a percent. Okay, so these, in my opinion, are the most difficult problems to do. So let's start off. It says what growth rate. When you see that, B is going to be missing. Right, so we're not going to have anything for our B. We don't know what the growth rate is. So our start value would be the first amount they give us, which is the 4,293. And we would multiply it by B. We don't know what the growth rate is, so we can't tell what our B is going to be. And then up here in the exponent, what do we put there in the exponent? That is going to be 18. That is our amount of time. And so from the year 2000 to the year 2018, 18 years have passed, right? So your time goes here. So we need to know, we know after 18 years that the population was 5,621. So we're going to put 5,621 here on the other side. Okay, so to solve this, okay, we first have to get rid of that 4,293. So 4,293, we're going to divide it on both sides. So we're doing here. And you can just use your regular calculator for this if you want. You don't have to use Desmos, just whatever you prefer. Since I've already got Desmos pulled up here, I'm going to use it. So I'm getting 1.3093407. And that's going to equal b to the 18th power. All right, who can remember how to get rid of that to the 18th power? What do you think, Katie? What? Yes. So we're going to raise this to the 1 over 18 power on both sides. Okay? On this side, it's just going to cancel out because we would do 18 times 1 over 18, which would just give us 1. And we would have b here. And then in the calculator, we're just going to copy this number, use the whole number, and we're going to raise it to the 1 over 18 power. And so I get 1.01508. So what was that? 6.2. It should be plenty. Okay, I'm going to stop here for a second. Questions? Julian, get your head up. Make sure you're writing this down. All right, so this is not our answer. So what this tells us is like our equation would look like this. 4293 times 1.0150862 to the x power. That's what our equation would look like. So the question asks us for the growth rate. This number is not our growth rate, but it's where we find our growth rate. Okay? So if I have 1.0150862 as my B, what would I do to find the growth rate? Very good. We subtract the 1. And you can do this in your head if you want. And then move your decimal 2 places back over to make this a percentage. So we got 1.50862%. I think the question says to round to the nearest thousandth of a percent. How many decimal places is that? Thousandth. 3. So thousandth is 3. We'd be cutting it off right here. So we do 1.509%. That last step is just the opposite of what we were doing on number 1, where we had our 7%, we changed it to a decimal, got 0.07, and added the 1. Right? We're just going backwards from that. We're subtracting the 1 and then changing it back to a percent. So we get 1.509%. Okay, questions? Okay. All right, so this here would be a good scenario for something like the pay it forward situation that we looked at in that very beginning, where you start with 1 and maybe you do good deeds for 4 people instead of 3, like we saw. It could be something like a rumor, like we make up some rumor about Julian, and I tell 4 people, and those 4 people tell 4 more people, and those 4 people tell 4 more people. So those are all possibilities there for your scenario. Money, unlikely. to be something you would use for this scenario. It could be something like, bacteria or something, because it does grow really, really rapidly and could start with just one. There. All right. For number 7, Owen, what's our initial value? Nope. 2. All right. Vince, what would the percent growth be on this one? What? Not just 4. It'd be 400. So it's the same process every time. You want to take your number, you're subtracting 1 from it, which is going to give you 4. But that is your decimal. You've got to move the decimal 2 places to get your percent. Okay. Okay, this is another one that it might be good for bacteria, something that grows really, really fast. It might be good. It could be something like 2 people have the COVID. They each give it to 5 people, something like that. It's got to be something that's spreading really rapidly. Yeah, you could say you have like 2 virus particles and it's growing.
So for the quiz, do you want us to give our own?
There will be multiple choice. So there will be ones that it gives you an equation, and then you have some to choose from, and you got to choose the one that can fit that scenario. So, like for example, if you had a scenario that said that you have 5 virus particles and they are doubling every hour or something like that, that would be wrong. It would not be correct because you start with 2 here, right? 2 is your initial amount, so you would be looking for one that has the correct numbers in the right place. So you won't have to write it out by hand and come up with it off the top of your head, but you will have to match it. I think it's 12, but it might be 14. It might, or 15. If it is longer, it's because it's got several of these where it just asks you for initial value or percent growth, and those are not worth as many points as the ones that are like the word problems and stuff. Okay, and our last one for this one, Hank, what is our initial value? Good. And Ayla, what is our percent growth on that one? No. No. Not 700. Nope. Alright, it's 0.7. So same thing every time. Subtract the 1. That gives you 0.007. And then move that decimal 2 places. So you get 0.7%. This would be a good one for population growth. It worked well for money if you don't have very good interest rate, which right now interest rates are horrible, so it would work. I think I get 0.1% on my, I think I get 0.15% on my checking account. I might get like 0.2% on my savings account. You're basically not getting anything. Yeah, you barely. There has, like, whenever interest rates are high, they might be 3 or 4% on a savings account, in which case you actually might make a pretty decent amount of money. You might, if you have $10,000 in the bank like this person, you might get, if you had $10,000 in the bank and you had a 3% interest rate, you get like $300 a year just for letting your money sit there. But at a 0.2%, we're talking more like $30 for letting it sit there.
So are we allowed to go in our savings accounts or just our parents?
It depends on how they have it set up. So it depends on how they have it set up. Like I have my children in a savings account, but they don't really have access to it. The bank could probably let them go in and deposit money, but they wouldn't let a 10-year-old take money out without a parental consent. As you get older, your parents might set up your account where you can get into the money. You know, you guys, especially like once you drive, you might have like a debit card or something that you might get. But you know, it depends on how it's set up.
How much do retired people make?
Depends on how much they made whenever they were working and how much money they saved.
So you get money every time you keep it in the.
Yeah, so for keeping money in the bank, so what the bank is doing is they're using your money. They are, like, you give them money and keep it in the account. And then they loan money out to other people to buy cars and houses and all, whatever else. So for using that money, they give you a little bit of interest. But a savings account, like, the bank has to give you your money back at any time with a savings account. So if you have $10,000 in the savings account and you decide you want to go take all the money out of the savings account, the bank has to give you the $10,000. So it is a very low risk investment, meaning that the bank's got to give you your money, and up to like $10,000, it's secured by the government. They have to give you your money. So interest rates on savings accounts are low because it's not very high risk. But if you invest in stocks or something, so if you have a company that you invest in, you are essentially giving your money to that company so they can use it to build their company. So they can build stores or buy inventory or do whatever they're going to do with it. So you're essentially giving your money to that company. Well, sometimes the value of that company goes up or down a lot. So each share that you buy can become worth more money or less money. So whenever you put your money in the stock market, you might make 20, 30, 40% sometimes. But if that company starts to do bad, then you might lose money. So savings account, you're never going to lose money. But something that's riskier like stocks, you could lose money. Typically, you can make more money with stocks, but if you're unlucky, you can also lose it. So you don't want to put money you have to have in stocks. That needs to be like investment
So
stuff.
basically, we're sharing money.
Yeah,
And
more or less, yeah. Yeah, and so and that's, like companies use that money whenever they are bought and sold on the stock market. They use that money to, I don't understand it 100%, but they use it to do different stuff with it. So that gives you an idea of what's happening there. So higher percentage rate growth, you're going to make a lot more money. Like right now, the savings account that I have for Hunter and Henry for like college savings, it's doing great right now, like 20-some%. So like the money that I put in there a few years ago is almost doubled already. But if the stock market goes down, it'll go back down. It's not, those are mutual funds, which are a little safer than just say like throwing all your money in Walmart stock or Apple stock or whatever else. Because if something happens, Apple and Walmart are probably relatively safe just because they're such big companies that they're. But especially like if Presley starts up a business and I invest in her, she might do great or she might flop. That'd be a risky investment. So like mutual funds are going to take, like you give your money to whatever company is doing the mutual fund, and they invest your money in lots of different stocks. Yeah, so your money, like they put it in the account, and it's in all of these different stocks. So I don't even know what it is exactly. I think I could go look it up. But like Hunter's savings account for that college fund, it might have, I'm just going to throw out companies because it might have like Nike stock, and it might have Apple, and it might have Walmart, and it might have lots of other different ones. I'm just throwing out things I know. It's probably got a lot of stuff that's not even related to that. But so if Nike starts doing really good, that's good. But if Nike starts doing bad, it'll bring it down, but not that much because maybe Walmart's doing better over here. So that's sort of how it works. They're less risky, but they still follow the market. So if the market's low, you can lose money on it.
So it's like
Yeah.
going up and down.
Yeah.
See it go down, you take the money out.
You can, yeah. Well, yes and no. When you see it start to go down, you can sell your shares, so you can take the money out. But Like, for example, that account that I have for Hunter is a special type of account that you can use for education savings. And so I don't pay taxes on it, and as long as I use that money for Hunter's college, I will never have to pay taxes on it. But if I take the money out now, I have to pay all the taxes on it because I've not paid any tax on it. So if I take it out to use it for anything else, like if I have some sort of emergency and need the money, I can take it out and use it for something else, but I would have to pay the taxes on it that haven't been paid. So depending on what type of account you have, if you just have stocks, you can sell whenever you see it start going down. The problem is sometimes whenever things start going down, they plummet, and you don't notice that. In general, you want to put stuff in things you can leave in there long term. And so it might go down, but you just sort of wait it out and it goes back up. And if you do mutual funds, then it's not like, oh, this company is crashing and burning and going out of business and you're just going to lose all your money. And like the companies will reinvest and stuff for you. So it's kind of interesting, but it works like that. All right. So we need to look at the other homework that you guys had from last night, and we'll see what time we get out of it. We got 10 minutes. All right, we're going to check this homework. I'm going to call out the answers first, and then we will. That's not the right part. Let's see. All right, let's see. That's not it. Here it is. Okay. All right, the first question is about Julie, right? Oh, shoot. This worksheet, whenever I did it before we could use Desmos, so I don't have the exact answer. So I'm going to need you guys to give me the exact answer you guys got, somebody that got it right. So for number 1, you should get somewhere between 14 and 15 years. What'd you get, Zach? 14.207 is what Zach is telling me, which sounds right. For number 2, you should get 2.6%. You could have possibly just rounded wrong, or maybe I did. I'm not sure really. Yeah, 2.59 is fine. Yeah. Yeah, same thing. Just rounded to a different. Number 3, you should get between 45 and 50 days. What'd you get? 49.83 days. There. She was really rounded on this. Crazy. Number 4, I got about 5 years. Is it like, it's like 5.00? Yeah, it's right there. 4.959. Yeah, we'll go 5 years. Number 5, I got 15 to 16 years. What did you get, Zach? 15.747. We used to have to use the table on the calculator and guess. So Desmos is much better. And then for number 6, you should get 5.9%. All right, so let's look at that first one that Passion asked about. So Passion, Julie invests $4,500 in an account that gets 5% interest compounded annually. If Julie wants her money to double, how long must she leave her money in the account? So let's just start with our equation. What is our starting amount? 4,500. Good. All right, so then we have to multiply that by that B factor. I know I'm growing at 5%. What should I use for my number right here? Not 0.5. So if I have 5%, if I change it to a decimal, I've got to move it 2 places. So I've got 0.05, and I've got to put a 1 in front of it. Or add 1 to it. If that was a number bigger than 1, we just add 1 to it. But most of these are really like this. All right, and then I don't really know how long. This is a how long question, so I'm going to put an X right there. All right, so on a how long question, you're going to go over to Desmos, I'm going to hit the house button, get rid of this stuff right here. And we're going to type in that equation. Y equals 4,500 times 1.05 to the x power. And I don't see anything at all right now. Why do I not see anything? My window is way too zoomed in. In general, always start with that Y. I know my start value is 4,500. So I'm going to go here, hit the wrench. I'm going to change that upper Y value to 4,500. And then from there, try to zoom out. And that gives me a better picture. I may still need to zoom out more. All right. Passion, what does this question ask us for? Okay, how long must she leave in her money account for the money to double, right? If she started with 4,500, how much will she have when it doubles? 9,000. Right, 4,500 times 2 is going to give us 9,000. So what the question's really asking is, when is she going to have $9,000? So I'm going to go down here and type in Y equals 9,000 right here. Nothing shows up, but look at my Y-axis. I'm not up to 9,000 yet. So let's zoom out a little bit more and we should be able to see it. And if I click right here, I'm going to get 14.207. So the answer for this one would be 14.207 years. Okay? All right, we are not going to get to the second worksheet that I was wanting to do today because we're on a short time frame. So your homework for tonight is to finish that worksheet. So do 7 through 12, is it? 7 through 12. So do those last 6 for me tonight. And then tomorrow we will look at that worksheet and that we were going to do today. And then we will take the quiz at the end of class. And Passion, I'm going to, during plan, I'm going to run up there and send just the calculator inactive part of that systems test up to Miss Wilburn and see if it's okay if you do that for me today.
Yeah.
And because I think that's what you guys worked on last night. And I will do that. So I'm going to have you take that part. And then after we get to look at some word problems, I'll get you to take the second part. Okay.
Are we going straight to third period, or are we going?
Oh, good question. If you have first lunch, you just go straight to lunch like always. If you have second lunch, you're going to go in the middle of third period. So if you have first lunch, go to lunch like always. Nothing really changes except for times for you. Second lunch, you're going to go during third period.